Hello students, welcome to experiencetutor.com. In today's class, we'll study class 11's mathematics complex number part 4.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Here we have a question. If 1 alpha alpha square and alpha cube alpha n to the power minus 1, it is minus 1. This is minus 1. Are the nth root of unity, then find the value of 2011 minus alpha, 2011 minus alpha square, 2011 minus alpha cube, 2011 minus alpha to the power n minus 1. Fine. Now let under root nth power of 1 is equal to nth root of 1 is equal to x. So which implies that x to the power n minus 1 is equal to 0, which has n roots. One alpha alpha square dot alpha n minus 1, say which implies that x to the power n minus 1 is equal to x minus 1 x square x minus alpha x minus alpha square x minus alpha q dot 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 x minus alpha to the power n minus 1 is equal to 0, which can be written as x to the power n minus 1 upon x minus 1 is equal to x minus alpha x minus alpha square x minus alpha q dot 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 x minus alpha n minus 1. Now putting x is equal to 2011, we'll get 2011 minus alpha 2011 minus alpha square 2011 minus alpha cube dot 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 2011 minus alpha n minus 1 is equal to 2011 to the power n minus 1 upon 2010. So it is not so clear, we can write it as 2010. We can generalize this result and this sums end here, the solution ends here, but let us try out something where we can generalize this result. Say we can write m minus alpha square m minus alpha cube dot 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 m minus alpha n minus 1 n minus 1. is equal to m to the power n minus 1 and m minus 1, where m is not equal to 1. If we take limit x tends to 1, then the equation will be 1 minus alpha 1 minus alpha square 1 minus alpha cube dot 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 1 minus alpha n minus 1 is equal to limit x tends to 1 x to the power n minus 1 x minus 1. This is equal to n. Therefore, we can also write m plus alpha m plus alpha square m plus alpha cube. If the series goes in this way, m plus alpha to the power n minus 1, it will give it will give 1 minus m to the power n upon 1 plus m into minus 1 to the power n minus 1. Now we have a problem here. Let a complex number alpha, where alpha is not equal to 1, be the root of our equation z to the power p plus q minus z to the power q plus 1 is equal to 0, where p, q are distinct primes. Show that either 1 plus alpha square plus dot 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 alpha p minus 1 is equal to 0, or 1 plus alpha square plus dot 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 alpha q minus 1 is equal to 0, but not both together. Now we know that the given equation, for the given equation z to the power p plus q minus z to the power p minus z to the power q plus 1 is equal to 0, which implies that z to the power p minus 1 z to the power q minus 1 is equal to 0. Therefore, either z to the power p minus 1 will be 0 or z to the power q minus 1 will be 0. Now we can write as alpha to the power p minus 1 is equal to 0, or alpha to the power q minus 1 is equal to 0. As alpha is the root for the given equation. Why we have written alpha? Because alpha is the root of the given equation. So alpha to the power, again we can write it as alpha to the power p minus 1 upon alpha minus 1 is equal to 0, or alpha to the power q minus 1 alpha minus 1 is equal to 0, implies that implies that 1 plus alpha square plus 1 plus alpha plus alpha square plus alpha q dot 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 alpha p minus 1 is equal to 0, or 1 plus alpha square plus alpha q plus dot 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 alpha q minus 1 is equal to 0. But both cannot occur simultaneously. Next problem is, let z1 and z2 be the nth root of unity which subtends a right angle at origin, and then n must be of the form 4k. So we have argument of z1 z2 is equal to pi by 2, and modulus of z1 z2 is equal to 1, which implies that z1 upon z2 will be equal to modulus of z1 upon z2 bracket cos pi by 2 plus I sin pi by 2 is equal to I, which implies that z1 upon z2 to the power n is equal to I to the power n is equal to z1 to the power n upon z2 to the power n is equal to 1, as z1 and z2 are nth roots of unity. Hence, hence z1 to the power n is equal to z2 to the power n is equal to 1, which implies that n is equal to 4k. Now we will go through the properties of modulus of a complex number. So, the first property, if z is a complex number, then modulus of z is equal to 0 if z is equal to 0, and modulus of z is greater than 0 if z is not equal to 0. The second property, minus modulus of z is equal to or smaller than equal to real z less than equal to modulus of z, and minus modulus of z less than equal to imaginary of z less than equal to modulus of z. Third, third, modulus of z1 z2 equal to modulus of z1 multiplied by modulus of z2. General equation can be modulus of z1 z2 z3 dot zn is equal to modulus of z1 into modulus of z2 into modulus of z3 modulus of zn. Fourth property is modulus of z1 upon z2 is equal to z1 modulus of z1 upon modulus of z2. Fifth is modulus of z1 plus minus z2 whole square is equal to z1 z2 z1 plus minus z2 no, it will be equal to z1 plus z plus minus z2 modulus whole square is equal to z z. So fifth one is modulus of z1 plus minus z2 whole square is equal to z2 modulus whole square plus z1 modulus whole square plus minus 2 re z1 z2 argument z2 conjugate z1 z2 conjugate which can also be written as which can also be written as z1 whole z1 square z2 square plus minus 2 real z1 conjugate of z1 into z2. Rule number 6. Rule number 6 is z1 plus z2 modulus is smaller than or equal to modulus of z1 plus modulus of z2. And generalization we can write it as z1 plus z2 plus z3 dot 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 zn is less than equal to z1 modulus of z1 plus modulus of z2 plus modulus of z3 dot 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 modulus of zn. Property number 7, modulus of z1 minus modulus of z2 is equal to less than equal to greater than equal to z1 modulus of z1 minus modulus of z2. If we take the modulus of both. Question number 6, 7 is done. Question number 7 is z1 plus z2 modulus whole square is equal to plus z1 minus z2 whole square is equal to 2 bracket modulus of z1 square plus modulus of z2 square. Property number 9. Modulus of modulus of z1 minus modulus of z2 is less than equal to modulus of z1 plus modulus of z2. Property 10. Property 10. Modulus of z1 plus modulus of z2 is equal to modulus of z1 minus modulus of z2, which implies that argument z1 minus argument z2 is equal to pi by 2. Property number 11. z1 plus z2 square is equal to z1 square plus z2 square, which denotes that z1 upon z2 is purely imaginary, is purely imaginary. Property number 12. If z1 is less than equal to 1 and z2 modulus of z2 is less than equal to 1, then modulus of z1 minus z2 square is less than equal to z1 modulus minus modulus of z2 square plus argument of z1 minus argument of z2 square and z1 plus z2 square less than equal to z1 plus modulus of z2 whole square minus argument of z1 minus argument of z2 whole square. Property number 13. Property number 13 is modulus of z1 plus z2 plus dot plus zn is equal to modulus of z conjugate of z1 conjugate of z2 plus dot plus conjugate of zn. Property number 14. The minimum value of the minimum value of modulus of z1 minus z2 keep it as z minus z1 modulus of z minus uh, z minus z1 modulus of z minus z2 this is the plus is equal to the minimum value will be equal to z1 minus z2. 15th is modulus of z square is equal to z z conjugate of z. Now we'll go through the properties of argument of a complex number. So properties of argument of a complex number. number. So the first property is argument of conjugate of z is equal to minus argument of z, provided z is a non-negative purely real number. Second property is argument of z1 z2 is equal to argument of z1 plus argument of z2 plus 2k pi, where k is equal to 0, 1 or minus 1. So we can we can generalize this equation as argument of z1 z2 z3 dot 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 zn is equal to argument of z1 plus argument of z2 plus argument of z3 dot 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 plus argument of zn, which is plus 2k pi, where k is an integer. Now third property is argument of z1 upon z2 is equal to argument of z1 minus argument of z2 plus 2 pi k, or 2k pi. So it will be better to write 2k pi. K pi, where k is equal to 0, where k is equal to either 0 or 1 or minus 1. Now property number 4, fourth property is argument of z upon conjugate of z is equal to 2 argument of z plus 2k pi, where k is equal to where k is equal to 0, 1 or -1. Argument property number 5. Argument of Zn is equal to an argument of Z plus 2k pi. Property number 6. If if argument of Z is equal to 0 or pi, then Z is purely real. Then Z is equal to real number. Then if argument Z if argument Z is equal to pi by 2 or minus pi by 2, then Z is purely imaginary. Then Z is purely imaginary number.
And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.